All right, today we're going to learn about sine and cosine. Now, you guys, last lesson, went over tangent ratio. With sine, cosine, and tangent, those complete the primary trigonometric ratios, okay? Also known as trig ratios. These two new ratios that you guys haven't seen before use the exact same sense as tangent. The only difference is they use other sides of the triangle to solve things, okay? So, the first thing we want to go through is if we're referring to this angle here. So, where were we? Sine. So the very first one, sine. If we're referring to this angle here, and what we're going to do is we're going to refer to the exact same angle in all three triangles so that you guys can see the differences between them. Our sine is known as the opposite over the hypotenuse. Well, what would be the opposite side from this angle? The base, the bottom. It'd be the side that's not touching the angle, right? All right. And then the hypotenuse. The hypotenuse is always opposite of which angle?
Right.
Of the right angle. Okay. So the hypotenuse does not change in any of our right angle triangles. And it's important to know that all of these ratios can only be used in right angle triangles. Okay. Sine, cosine, and tangent ratio only are used in a right angle triangle. So that would be our sine ratio. In our second angle, let's say we're talking about cosine. What would be the adjacent side to this?
Oh.
Yeah, the one to the left here. Good. So this would be considered the adjacent side of the triangle. Since we already know the hypotenuse, that would be this side over here. GUSC. Okay. And finally, you guys already know tangent, but we'll go over it anyways. This would be our opposite side in tangent ratio. And this would be the adjacent side, okay? So, the only difference between the two new ones is that they refer to different sides of a triangle, and it completely depends on where the angle is. If the angle is down here at the bottom, this would be the opposite side. The hypotenuse would stay the same. And if this was the angle, this would be the adjacent side, and the hypotenuse would stay the same. What we'll do next is we're going to actually go over a couple of triangles, solving for the angle and the side. So, a common mnemonic device to remember this is called SOHCAHTOA. And the reason they use this to help remember is the S stands for the sine, and sine is equal to the opposite side divided by the hypotenuse. Cosine is equal to the adjacent side divided by the hypotenuse. And tangent is equal to the opposite side divided by the adjacent. Okay? So this is a mnemonic device to help you remember, in case you can't remember that sine, cosine, and tan, what their ratios are. All right, so keep that in mind. You can always write that at the top of the test. So we have a question here, and we're going to solve for our theta, this angle here. I'm going to use either sine or cosine for both. So sine theta is equal to, well, in this case, sine is what? What's the ratio for sine? Opposite over hypotenuse. What's the opposite here? Okay, and what's the hypotenuse? 12. Good. So our sine is set up as 8.9 divided by 12. What if we were using cosine to solve for that angle? Cosine theta is equal to, what is cosine theta's ratio? Adjacent over hypotenuse. What's the adjacent side? And we already know hypotenuse is 12. So we have 8 over 12. Now, because we're solving for the angle, we need to get the angle by itself in this question. In order to get the angle by itself, we want to move the sine or cosine to the other side, hypothetically. So, when I move sine to the other side, or if I'm solving for an angle, what does that look like on your calculator? Good. Sine inverse, whoops, it's just to the power of -1. 8.9 divided by 12. Okay. And in the other case, theta would be equal to cosine inverse of 8 divided by 12. So we'll bring up a calculator and try this now. Now, your calculators might be mine, where I actually have to solve the ratio first and then type it in. Or you might be able to type this all in as one equation. In mine, 8.9 divided by 12 is equal to, and then I have to do the inverse of sine, 47.87. Okay? So theta is equal to 47.87. Let's try that same ratio with cosine. 8 divided by 12 equals, and inverse of cosine, 48.18. Oh, that one said 48? Oh. And the other one was 47, right? 8.9 divided by 12. Let's just double check here. Yeah. So what happens is there's a bit of a rounding in this one. Okay. I'm assuming the triangle that the textbook gave us here probably was a bit longer and they rounded it to 9. There were probably a couple other numbers that we could have added into this and it would have made it a little more accurate. Okay? But in both cases, 47 rounded would have been 48. So we found the same angle. Okay? 1 degree is very small in terms of angles, but we should be able to find that same degree. So in both cases, they're approximately 48 degrees. Approximately. So we solve for an angle. Oh, we put up another triangle here. Okay? In this triangle, we want to solve for side A and side B. So, in each case, we actually want to use a different ratio. With my 50, if I'm looking for A, that's the opposite side. My hypotenuse is 20. Which of the ratios deals with opposite and hypotenuse? Sine is opposite over hypotenuse. So sine, and the angle is known, so sine 50, replace theta with 50, is equal to the opposite is A divided by 20. Okay? Let's say I was solving for B. B would be known as the adjacent. Which ratio is adjacent in hypotenuse? Cosine. So cos 50 is equal to the adjacent, which is side B, divided by 20. Okay? So when dealing with the same angle, we can solve different sides depending on whether we use sine or cosine. Okay? So, now, if I want to isolate A, what do I have to bring to the other side? And how do I do that? That's right. So this will read 20 multiplied by sine 50 is equal to A. And on this side, 20 multiplied by cos 50 is B. So we'll go to our calculators here. I got to do sine 50 first. So 50 sine times 20, 15.3. So side A is 15.3. And side B is 50 cosine times 20, 12.8. So I solve for different sides of the triangle, completely depending on whether I used a sine ratio or a cosine ratio. Okay? So importantly, make sure you remember these. SOHCAHTOA, they're used the exact same way tangent is used, and we went through it with tangent. We're just going to be really just hitting a different button on our calculator. The toughest part is setting it up and knowing which of the 3 ratios we need to use.